We will be drunk and all of our thumbs went up in the air. Singing in the wind, listen to the thunder rolling over and over. We down, we're getting on fire, we're raising up higher. The bottle is up, we're over the top, it's time to get wild. The time of our life is happening now. We're out of control together.
Welcome to another edition of STEM communication. We're looking at one of STEM subjects, which is physics, and we're looking at a topic that I call dimensionless physical quantities. Dimensionless physical quantities. This topic is very important to beginners in science, especially in physics, whether from senior high school 1, 2, 3, down to advanced and down to the university. You've got to know those quantities that are dimensionless. Why are they dimensionless? What does it represent when we say a quantity is dimensionless? How do you know that a quantity is dimensionless in physics? This is the journey we intend to embark on in this particular STEM communication. I seek for your attentiveness. Now, you will recall in one of my video production on quantities, physical quantities, I said the foundation to science, everything you learn in science, mathematics, technology, engineering, at any level, all begin from physical quantities. Just like food, shelter, and clothing is the three most essential foundation to human existence. Physical quantities, especially the basic ones, which are 10 in number, and 3 being the most essential, mass, length, and time, are also the foundation to everything that you learn in science. It's the foundation to everything that you learn in science. And that is why physical quantities, I classify them into 7. I mentioned the first 10, basic, fundamental, called basic physical quantities. Then from basic, we have derived. Then we have those that are scalars, those that are vector. Then there are some that are described as completely dimensional. I will explain that today. And partially dimensional. This two is not very common. You hardly see this in any textbook of science or whatever. But we need to split it and make it clearer and differentiate. When we say a quantity is completely dimensional, and when we say a quantity is partially what? Dimensional. I'll quickly spend like 1 or 2 minutes on that before I now go to the 7th one is dimensionless quantity, which is the one we want to discuss today. You need to identify all the quantities that are dimensionless. Now, before I go into all that, let me quickly differentiate between a quantity being completely dimensional and being partially dimensional. Let me start with partially dimensional. You will recall that the period of oscillation T is actually time taken for a particular number of oscillation over the number of that oscillation. Now, if you look at this formula, T is period of oscillation. T is the time taken for a particular number of oscillation, which is n, and n is the actual number of oscillation. If you look at this, anything that is number, just like we have here under this Reynolds number, once you hear number, it is dimensionless. Number does not have dimension. So this one, it means that this capital T is as good as saying this small letter t, the time taken. And that is why the unit for period is second, because time is in second. Okay? So you can see that here, in deriving the formula for time and the period of oscillation, it is partial. We couldn't substitute any dimension or unit for this n because it's not part of basic. It's not basic. So it disappeared. You take it as just 1. Okay? Even though the number of oscillations will be 20, in dimensional analysis, you will take it as what? 1. So this formula, as far as it's concerned, is partially dimensional. Now let's look at the one that we said is fully dimensional. For example, when you say quantity is fully dimensional, let me take potential energy, for example, which is mass and acceleration times height. If you look at this, all the physical quantities here are replaceable basically or fundamentally using fundamental dimension. Mass is capital letter M, that is the dimension for mass. Acceleration to gravity is L over T squared. Then height means length. Height is also length. Dot L. You can see that here all the physical quantities are completely replaceable. So please take note of that. We make that classification so that it will be very, very clear for everyone to see and understand. So I clean this up. I don't need this again so that it doesn't interrupt with what we really want to discuss today. Now again, what do we say a quantity is dimensionless? Now there are some quantities that are dimensionless but they have units. Some quantities are dimensionless. Some quantities are dimensionless. We have two classifications with units. There are some without units. Now, if you recall, under the 10 fundamental quantities, I told you that the last three are supplementary. The last three, which are the plane angle, the solid angle, and the radioactivity, they are actually dimensionless quantities, but they have units. So if I ask you, name 3 fundamental quantities that are dimensionless with units, what I'm saying is plane angle, that is radian, that is the unit. Solid angle, steradian is the unit. Radioactivity, that is Curie, that is the unit. So we have already treated this in one of these STEM communications. So try to find out by subscribing, sharing, and supporting, okay? So you get all those details there. So these 3 quantities, they are dimensionless, but they have units. But today, we are interested in, I want to clean this up also because I don't need this again. It's just trying to make that clarification. Okay? There are some quantities that are dimensionless. They have no dimension. You cannot symbolize them, just like you cannot symbolize these 3. But yet, they do not have unit also. Those are the ones we want to really discuss. So take note that dimensionless quantity can be classified into 2. Those with units, there are just 3 of them. Plane angle, it has the unit of radian. Solid angle, it has the unit of steradian. And radioactivity, it has the unit of Curie. You remember that famous scientist, Madame Curie, that really did a great work in the nuclear world. Then, those without units are the ones we really want to discuss. Okay? Now, I want to clean this. Now, when we say a quantity is dimensionless, in this context of classified physical quantities, it means they are quantities that, number one, they do not have dimension. You cannot represent them with any dimension. And once anything does not have dimension, automatically you cannot replace them with unit because it is dimension that leads to unit creation or unit existence. So when we say a quantity is dimensionless in science, dimensionless, it means that quantity can be taken as 1. Take note of that. That quantity, you can replace it with 1. The symbolic representation of dimensional quantity is 1. So we are going to see that in this discourse. Now, I came up with quite a number of this type of quantities that are dimensionless in physics. Now, for you to really be able to know if these quantities are dimensional or not, you need to know the formula or equation that they are connected with. For example, we are starting with coefficient of friction, which is rho, this unit. Coefficient of friction. Coefficient of friction. The first one, coefficient of friction. You remember that force equals to rho times reaction. You remember this formula under friction? Force is in Newton, reaction is also in Newton. So if you make this coefficient of friction, the symbol, the subject of the formula, what you have is F over R. Now, technically, force is in Newton. Reaction force is also a reaction. Reaction force is also a reaction. It's also in Newton. So Newton cancels Newton. So there is no unit. So that means this is dimensionless. Is that clear? Okay. So let's look at another one. Then I will just take a few of these examples and then try to explain the other one to you for you to be able to understand. Now, strain. is also another dimensionless quantity. Why is it dimensionless? Strain, epsilon, that's the symbol, is extension over original length or natural length. Extension. Now, extension means final length minus initial length when an object is being imposed over the initial length. Now, if you look at this, length is LF minus LI is L, is length, dimension. Then LI is also dimension L. L cancel L. What do you have there? It's 1. So, strain under elasticity, okay, change in extension of our original length of a strained material is dimensional because it ended up giving us 1. Remember I told you 1. Okay. Now, I want to pick another one. I want to pick this pi. Pi as a physical quantity. Why is it dimensionless? You will recall that circumference, which is known as perimeter, is of a circle is 2 pi r. Now, if you make this pi subject to the formula using this, pi will be perimeter over 2r. Now, I told you that perimeter means length, means distance, that is L, divided by 2. Radius, look at it, radius is also length, so that is L. Now, in the dimensional analysis, we don't deal with number, this disappears. So, what we have left? L over L. Okay? So, this L over L gives us what? 1. So, it means that the dimension for pi, which in actual sense is 22 or what? 7, now becoming 1, has no unit, is dimensionless. Okay? Now, let's go to another one to showcase that dimensionless quantity does not have dimension and they do not have unit. Let's look at velocity ratio. Velocity ratio in machine study. Okay, VR, that is VR, velocity ratio. Velocity ratio is defined as distance moved by effort over distance moved by load. Distance is L. Anyway, you talk about distance is L. Distance moved by load, distance is also L. You can see that it has no dimension again because this will result into 1. So, with this, it means that once you know the formula for each of these quantities, which I'm going to discuss for the remaining one, then it becomes easier for you to be able to prove whether they are dimensionless or they are dimensional. So, now, we have done this. Relative density. That is when you are comparing the density of any substance with the density of water. So it means density of a substance over density of water. Do you see that? I'm talking about density in the numerator, density at the denominator. Density cancel density. It disappears, no unit. Specific gravity also is also comparing density of any substance with density of water. So it is the same as this. These two are the same. Okay? Mechanical advantage is load over effort. Mechanical advantage, ME, is load over effort. Load is a force in Newton. Effort is also a force in Newton. Newton cancel Newton, no dimension, no unit. The refractive index in the study of lens and mirrors and others is actually equals to what? N equals to sine of the incident angle over sine of the refracted angle. Anything sine, cosine, tangent in mathematics is number. Number over number does not have no unit. Sine of any angle, cosine, tangent, cosec, cotangent, once it's an angle of any angle is dimensionless. So that is why the refractive index is dimensionless. Efficiency of a machine. Okay, let's look at that. Efficiency of a machine. Efficiency E is work output over work input. It also means listen, we have in-depth energy fraction, I've done that. Then we have Reynolds number. Reynolds number, anything that is Reynolds number, or any of such numbers, if it's there, quite a number of them. Once number is being mentioned, you should know that even though it's a physical quantity, it is dimensionless. So with this, our take home here is that anything that is dimensionless can be classified into two. We have dimensionless quantities that have no units, and we have dimensionless quantities that have no units and no dimension. We have some that have no dimension, but they have units. The ones that have dimension and they do not have, the ones that have units and they do not have dimensions are under the supplementary component of the fundamental quantities, the plane angle, the solid angle, and the radioactivity. Then every other one do not have both dimension and they do not have unit, and that is what we have discussed. We have about 13 of them listed here. You should be familiar with all this. So with this, you have come to the end of our topic, dimensionless physical quantity. I believe anytime you come across this in your study, you'll be able to know, oh, this quantity is dimensionless, this one is not dimensionless. So that's the end of today's STEM communication. Please always subscribe to our channel, YouTube channel. You share it with your friends, relatives, neighbors, all over the world, all over the continent. Then you support us also. Okay? You can support us in different ways. As time goes on, we'll be telling you various areas that we need your support, because we are really interested in imparting our world by communication. Don't forget, it is through communication everything that comes into existence comes to reality. And I cannot tell you enough the testimony of students that have listened to my communication that have excelled. About 15 years ago, or around 2012, 11-12, a student came through my program, and then we came for my coaching program. Then I was in a learning, and we coached her, and then she gained admission to Covenant University to go and study. At the end of 5 years, after not seeing her for a very long time, I just saw her in my office. She came to invite me for her matriculation, and she wanted to make me the chairman of the occasions. She came out with a first class. What was her testimony? She told me all through her 5 years at Covenant University that it was the 3-month encounter coaching she came in for JAM that took her through. That the foundation that I laid was what saw her through the 5 years program she did at Covenant University. That tells you the power of words. We exist by word. God created the earth, everything, plant, soil, cut by word of man. He said, let the water give out the fishes, the creatures of the water. And the earth also spot out everything that is, you can see as plants. It is only human being he didn't create by word. Okay? But you know what he did? He gave us word that he didn't give to other creations, language. And by language, you communicate. Through communication, anything can emerge. People like Elon Musk and the creator of Facebook, Twitter, Threads might have listened to a word from a motivator, from a mentor, a teacher, a nation builder. That word may be the one that is making them to be creating things. And so as you listen to this type of communication, listen, it may just be just one word, it may just be this poison ratio or this pie that God is going to ignite. Used to ignite something inside of you that will make you to come with a technology that will stand you out in the workplace. And so please, as we make ourselves available for this, do not forget to support us.
Down the river we drunk and all of the thumbs went up in the air.